Welcome to the Explainer. We've all done it, probably a dozen times today already. You type in a username, a password, and you click login. But have you ever stopped to wonder what actually happens in that split second? Well, today we're pulling back the curtain and demystifying web authentication. And look, if you've ever felt like this quote here, you're in good company. For a lot of people, the whole login process feels like some kind of scary, magical black box. You put your details in, and poof, you're logged in. But how? So let's go ahead and open that black box. We're going to follow the entire journey of a single login request, from your browser all the way to the server and back again. We're going to uncover the secrets behind this everyday action that most of us just take for granted.
Now, to really get why logging in is designed the way it is, we have to start with the fundamental problem it's trying to solve. And that problem is, honestly, the web has a terrible, terrible memory.
See, the protocol that powers the web, HTTP, is what we call stateless. And that's just a fancy way of saying it has amnesia. Every single time you click a link or visit a new page, the server treats it like it's never seen you before. It asks, "Who are you?" over and over again. It's like having to show your ID to get into every single room of a building you're already in. It would be completely unusable. So to get around this forgetfulness, servers have to set up these digital security checkpoints. When your login information finally arrives, it doesn't just get a simple thumbs up or thumbs down. Oh no, it has to run a gauntlet. In the world of web frameworks, we call these checkpoints middleware. Your request has to pass through a whole chain of these things, and each one has a specific job to do. The best way to think about it is like the security line at an airport. And somewhere in that line, there's a specialized agent whose only job is to check your credentials and verify you are who you say you are. And that brings us to the most critical, most sensitive part of this whole process, the password puzzle. How on earth does a server confirm your password is correct if, and this is a big if, it's not supposed to know what your password is? Right, because here's the absolute #1 cardinal rule of web security. You never, and I mean ever, store passwords as plain text in a database. It's a disaster waiting to happen. If a hacker gets in and sees a list of passwords, it's game over for every single user. So what do they do instead? Hashing. Instead of storing your password, the server stores a hash of your password. A hash is basically a unique, irreversible digital fingerprint. You can turn password123 into that long, jumbled string of characters, but there is no way to turn that string back into password123. It's a one-way street. And to make things even more secure, they add something called a salt. A salt is just a little piece of random data that gets mixed in with your password before it's hashed. This means that even if you and I have the exact same password, our hashes stored in the database will be totally different. So when you log in, the server just takes the password you typed, adds your unique salt, hashes it, and then compares that result to what it has on file. Okay, so you're in. The server has verified you. But remember the web's amnesia problem? How does the server remember you when you go to the next page? Well, it hands you what you can think of as a digital hall pass.
This is a brilliant two-part system. On the server side, it creates a session, which is the official record saying, yep, this person is logged in. Then it gives your browser a tiny little file called a cookie. That cookie is your ticket, your hall pass. It doesn't contain your password or anything, just a unique ID that matches the session record on the server.
All right, so let's put it all together and complete the journey. What happens when you've logged in and you try to visit another protected page on that site? And here is the whole beautiful flow. The first time you log in, you get your cookie. From that moment on, every single time you request a new page, your browser automatically flashes that cookie at the server. The server sees the ID on the cookie, looks up your session, and says, "Ah, I know you. Come on in." All without you having to type your password again. And that's really the key takeaway here. That little cookie acts as a trusted token. It's your proof of an established, secure session that lives on the server. This elegant dance between sessions and cookies is the classic, time-tested solution to the web's fundamental problem of being so forgetful. Now, everything we've talked about is what's called authentication. That's all about proving who you are. But that opens the door to an even bigger topic, authorization, which is all about what you're allowed to do. This is where systems like Sign In with Google come in. They're less like a simple hall pass and more like a special all-access badge that grants very specific permissions. Which leads us to a much bigger question. Is there one single perfect way to manage our identity online? Well, that's a conversation for another day.
But for now, you know the fundamental blueprint that makes it all possible every time you click Login. Thanks for watching.